Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael C. Ndinechi. The topic today is Introduction to Computer Engineering. The word literacy has different meanings to different people. However, no matter the meaning, literacy is the most important goal of education. Every person should be able to read and write. Just as it is believed that mass literacy is essential for all citizens, computer literacy has become even more essential. Is there anything so important about computer literacy that makes it pertinent for every citizen to learn it? My answer is yes, because falling out of step in the rush to computer literacy can leave one at a permanent disadvantage. Information age. In the 20th century, most people in developed nations worked as blue-collar workers in factories. By the end of that century, over 80% of the people worked as information workers and no longer as manual workers. In other words, their jobs were to receive information from others, to process information in various ways, and to pass information along to others. The computer was then designed to do just only these three things: receive, process, and give back information, the very things that all information workers do. Therefore, a person's skill in using computer systems will largely determine his or her value in the present digital economic era. However, there is more to computer literacy than access to jobs and careers. Computer literacy holistically means being able to tell a computer to do what you want it to. To tell a computer to do anything, you must understand exactly what you want done. If the computer does not do what you wanted, you must think again about the instructions you gave to it. To tell the computer to do what you want it to do, you must have a language to do the telling. Such languages are called programming languages. You cannot use a computer without giving it instructions, that is, programming it. In short, programming skills together with computer operations form the backbone of computer literacy. The computer in our lives, we make use of calculators, digital watches, computers, our cell phones. All the electronic gadgets you use today are having computer residing inside them. The above examples are just a tip of the iceberg. The fact that computers can store information makes them different from every other machine ever invented. Before a computer can do anything for you, it must be told the rules and tactics of what you want it to do. This information is contained in a computer program. A program, therefore, is a list of instructions that the computer carries out, one at a time. With a different program, the same computer can carry out many other different tasks. The knowledge inside any computer was put there by somebody. For instance, before a computer can play any game, a good player has to write the rules and tactics into a program and then put the program into the computer. After that, the computer can play the game, but only as well as the person who wrote the program. If the computer can play only one game, we say that it is dedicated to carry out the steps of one program. The programs in the computers you use will probably be easily changed. Such computers are called general purpose computers because by changing the programs in them, they can easily change what they do. If you put a chess playing program into a computer, in a few seconds, it will play chess for you. If you load a calculator program in it, it will help you solve complex arithmetic problems. Communicating with the computer. To use a computer, you must be able to communicate with it. You must tell the computer what you want done and must understand the messages that come back from the computer. Working with the computer is like having a conversation with another person. There is a time to talk and a time to listen. You talk to the computer by typing on its keyboard, and you listen by reading words on the screen. If you talk when you should be listening, the conversation gets confusing. The computer has a way of signaling when it is ready to listen to you. It puts its cursor on the screen. The cursor is a small square of light that flashes on and off. If the cursor is not on the screen, the computer is not paying attention to the keyboard. You also have a way of signaling that you have finished talking to the computer by pressing the return or enter key. After that, the computer accepts your message, does what you ask it to do, and puts the cursor back on the screen. Now, what is this computer we're talking about? From the discussion so far, we already know a lot about what a computer is because we know some things it can do. We will learn more about how a computer works later. A computer, therefore, can be described as a piece of electronic equipment which, when given some data, we process it in some predefined way and produce some results that are sent to the user through its output. A computing machine requires some means of accepting data called input port, somewhere to store the data called the memory, and somewhere to keep the sequence of operations to be carried out called the stack. It also requires some means of manipulating the data or performing the calculation called arithmetic logic unit, ALU, and finally a method of telling the user the result of the calculation. These facilities are common to all computing machines regardless of the task the machine is used for. A computer system, on the other hand, takes the basic form of computing machine with the addition of a software. The addition of software makes the computer system more flexible so that it can be used to solve different types of problems. History of computers. Computer history is better considered by its evolutionary trends and according to the different stages of their development called generations. Before 1935, we were mostly mechanical machines which perform one or two functions. The early Egyptian abacus was also regarded as a counting computer. However, other milestones in computer evolution exist, as shown below. Starting from 1641, Blaise Pascal invented machines that can do addition and subtraction with automatic carry transfer and complement number representation. 1671, Leibniz invented a machine called the step reckoner to do division and multiplication. Then Jacques Lomes invented a computerized looming machine for weaving patterns and directions. Between 1814 and 1834, Charles Babbage designed the analytical difference engine to perform simple calculations. It used the principle of constant difference to evaluate mathematical formulae. Charles Boole wrote a book in which he introduced the mathematics of symbolic logic known as the Boolean algebra. This formed the framework for complex digital system design today. The concept of Boolean algebra in digital computers will be treated in later model. The Hermann Hollerith developed a method for sorting and processing data by use of mechanical recording and tabulating devices. This is machine, after several and subsequent developments, become known today as the International Business Machine, IBM. In 1924, John Atanasoff made the first attempt to build electronic computer using vacuum tubes to solve simultaneous equations. In 1937, Professor Howard Atkin designed the Mark I computer at the Howard University. Between 1946 and 1943 and 1946, John Maclay and J.P. Eckert invented the electronic calculator called ENIAC. John von Neumann developed the store program concept. This concept allowed for the storage of program and data in the same memory. This development was used to develop the EDVAC computer. In 1946, Professor Mark M. Wilkes developed the electronic delay storage automatic computer. This leads us to computer generations. The first generation of computers, since 1944 to 1955, computers of this generation were characterized by cathode ray tubes, vacuum tubes, and they were large and expensive. They could only be programmed in binary and were very bulky and had reliability problems and high heat dissipations. They were very slow, process one job at a time, and make use of magnetic tapes for storage. The second generation, 1955 to 1963, saw computers utilize primary discrete transistors and magnetic disk technologies. Typical machines here are the IBM machines. They had limited capabilities but were more advanced than their predecessors. Third generation, 1964-1973, this generation utilizes integrated circuit technologies, that is small-scale integration and medium-scale integration with IC memories replacing the ferrite core and magnetic drum memories. This generation of computers also began to witness low power requirement, low heat dissipation, and faster execution time. It saw the evolution of microprogram control, hardware control, as well as support increased use of parallel processing, multi-programming, and multiprocessing, and uses operating systems OS. Fourth generation, 1974 to 1984, saw the use of large-scale integration, LSI, and very large-scale integration. These computers were very fast and small, relatively low price, and easy to use. Microcomputers appeared in this generation. They have limited I/O and floating point capabilities, as well as use programming languages. Examples were Intel 8085 to Intel 8286 processor-based systems and Apple Macintosh. Fifth generation computers, 1990 to 2000, it was expected that those computers were intelligent with intelligence capabilities belong to these generations. Some of the features of this generation include, but not limited to, the use of application-specific integrated circuits, superconductors, and fuzzy logic. Uses of computers. We use computers because of these basic reasons: processing speed. Computers are very fast in carrying out tasks. They can sort thousands of records into alphabetical or any order in less than a couple of seconds. They can perform complex calculations in a thousandth of a second or other programs. The slowest computer we have a speed of better than 3 megahertz, with many going as far as 300 and more megahertz. The important thing to note is that a computer that makes use of 100 megahertz means that it will process one piece of information in 0.01 microseconds. Finally, the number of instructions or operations that a computer can handle in a fixed time period is also used for speed rating. Hence, a computer rated at 2 MIPS or 2 MOPS will do 2 million instructions per second or 2 million operations per second. Another reason we use computer is adaptability and flexibility. As already stated, a computer can be configured as a general purpose machine. Thus, you can adapt a computer to play games and the same computer to do word processing or even be used to solve complex mathematical models. Accuracy: once a computer system is set up to work properly, it will always work correctly without errors over and over again. Storage capacity: the primary role of computers is to take data and convert it into useful information. This data must be stored before it can be manipulated. In fact, some modern hard disks can store as much as 1 year edition of any daily newspapers. Other uses of computers include in hospitals, in research establishments, in printing industries, in offices for database management and management information systems, in businesses, and in any other area you think of. Disadvantages of using computers: everything has to be stated exactly the way you want it or the way a computer will understand it. This is referred to as garbage in, garbage out. Computer brings about automation in industries. It is a well-known fact that automation brings about both blue-collar and white-collar job displacements. New technologies may solve existing problems, but it also will introduce new problems, many of them unseen at the point of introduction. Thank you for listening. Please like, share, and subscribe. Drop your comments, questions, or topic you want me to lecture on in the comment section.